All right, same lesson, but video number 2, we're going to talk about resultant force. I started this video already and got interrupted, so I had to start it again. So I whited out everything the best I could. So let's talk about what a resultant force is. If you have 2 or more forces acting on an object, the resultant force is the sum of the 2 vector forces. So we're going to have 2 things acting on one object. And again, that's a resultant force. Let's look at problem number 7. 2 tugboats are pushing a barge. So that's your 2 forces acting on one object. The 2 forces are the 2 tugboats, and the one object is the barge. Okay, tugboat A is traveling in a direction of south 80 degrees east. So let's go over here. Okay, south and east. Now remember, this is a quadrant bearing, so the angle that you're given is going to be the acute angle between the vector and the y-axis. So 80-degree angle right here. Okay, and we're in the 4th quadrant because we're south 80 degrees east. And then it tells us tugboat number 2 is traveling in the direction of north 65 degrees east. So north and east is going to be my 1st quadrant. So my 65-degree angle is going to be right here. Okay, and the boats are pushing with a force of 400 pounds. Find the magnitude and direction as a quadrant bearing of the resultant force of the barge. Okay, so let's go ahead and write down our vectors. I'm letting tugboat A be vector 1, and I'm letting tugboat B, that's vector 2. Okay, so I'm going to have my force, which is going to be my 400 pounds right here. That's going to be my magnitude. And then I'm going to multiply it times the cosine. So let's figure out what our angle is. So starting at the positive x-axis, I have 90, 180, 270, and then I have 270 plus that 80-degree angle there, which is going to be 350 degrees. So 400 times the cosine of 350 degrees. And then I'm going to have 400 times the sine of 350 degrees. Okay, so that's vector 1, which is going to represent tugboat A. Now let's find vector 2, which is going to be tugboat B. Okay, so once again, we'll have 400 times the cosine. So in order to find out what this angle is, we're going to start at the positive x-axis and go up to our vector. So that's going to be our little angle right here. So since this part is 65, this part has got to be 25 because this entire part is 90. So 90 minus 65 is 25 degrees. So we'll have 400 times the cosine of 25 degrees and then 400 times the sine of 25 degrees. Okay, so I've written these in component form for vector 1 and vector 2. Now let's go to our trusty calculators. And let's get our decimals. And again, let's go out 2 decimal places. That seems like a good idea. So in my calculator, I'm going to do I'm going to turn it on because that's the thing to do. We have 400 times the cosine of 350. So it's 393 and 92 hundredths. Okay, and then we'll do the sine. 400 sine of 350. So that one's going to be negative 69 and 46 hundredths. Okay, now let's do the other one. 400 cosine of 25. I'm going to go ahead and do 400 sine of 25 while I'm here. So 362 and 52 hundredths, and then 169 and 5 hundredths. Okay, so I found my component form for vector 1 and vector 2. So to find the resultant force, we need to add the 2 vectors together. So remember, we'll take vector 1 and add it to vector 2. So take your 393 and 92 hundredths and add it to your 362 and 52 hundredths. And that's going to give us 756 and 44 hundredths. Okay, Now let's take our negative 69 and 4600ths and add it to our 169 and 500ths. And that's going to give us 99 and 5900ths. Okay, so take a moment and soak that in. Okay, that's going to be our resultant force. And then it's asking us to find the magnitude and the direction as a quadrant bearing of the resultant force of the barge. Okay, so this is the resultant force. We found both vectors and we added them together. But then we're going to go one step further and find the magnitude and the direction of the resulting force of the barge. Okay, so let's go ahead and find the magnitude. The magnitude of vector 1 plus vector 2 is going to be 756 and 4400ths squared plus 99 and 5900ths squared. And then take the square root, and that'll give you your magnitude. Okay, so let's go over here and do second square root, and we're going to do 756 and 4400ths squared plus 99 and 5900ths squared. Okay, what are we going to get? 762 and 9700ths. Okay, now this is actually a magnitude or a force. Force is being measured in pounds here. So we are going to measure this magnitude in pounds. Okay, so now let's do our direction angle. So we'll put B over A. And then we're going to find the inverse. Okay, so second tangent of 99 and 5900ths divided by 756 and 4400ths. What's that going to give me? 7 5/10. Okay, so 7 5/10 with this angle being in the first quadrant is going to be right here. But we're wanting to write this as a quadrant bearing. So what I'm going to have to do is I'm going to have to take 90 and subtract my 7 5/10 to get 82 5/10. Okay, so I'll have 82 5/10 degrees. Since it's in quadrant 1, it'll be north of east. Okay, and that's your answer. So we found the resultant force by finding vector 1 and vector 2 and adding them together. That's my resultant force. And then it asked me to go one step further and find the magnitude and the direction of my resultant force. So that's why we did all of this. Okay, so this is the resultant force. This is the magnitude of the resultant force. And this is the direction of the resultant force. Okay, that decimal is not very visible, is it? All right, so as you're doing the next two problems, be very careful to notice what they're asking you to do. On number 7, they're asking you to write the direction as a quadrant bearing angle. Okay, and number 8, they're asking you to find the direction to the positive x-axis, just a regular angle. And then on number 9, they're asking you to find the direction with respect to the horizontal of the resultant force. Okay. All right, so y'all work these out and send them in, and y'all have a great day.